Limiting factor. This is one more important concept in stoichiometric calculations. We know that in a stoichiometric calculation, the reactants and products are involved in a fixed ratio. That ratio will not change. For example, if sulfur is reacting with oxygen to give sulfur dioxide, here atomic weight of sulfur is 32, molecular weight of oxygen is 32, and molecular weight of sulfur is 64. It means that 32 units of sulfur is reacting with 32 units of oxygen to give 64 units of sulfur dioxide. Units means it may be 32 grams of sulfur will react with 32 grams of oxygen to give 64 grams of sulfur dioxide, or 32 kilograms of sulfur reacts with 32 kilograms of oxygen to give 64 kilograms of sulfur dioxide. Similarly, 32 tons of sulfur will react with 32 tons of oxygen to give 64 tons of sulfur dioxide. That is, whatever the quantities that they are reacting, they react in a fixed ratio to get the compound. So this reaction will not change whether you take in grams or kilograms or tons. But the ratio will not change. Now what happens if this ratio was not followed? That means if one of the substance was taken in excess amount, in such cases what happens? For example, instead of 32 grams of sulfur, if you have taken 40 grams of sulfur and it was allowed to react in presence of 32 grams of oxygen, then what happens? Whether the 40 plus 32 gives 72, just like 32 plus 32 64? No. Even though if you have taken 40 grams of sulfur, out of this 40 grams, only 32 grams of sulfur will react with 32 grams of oxygen to give 64 grams of sulfur dioxide. Then what about the rest of the sulfur? Here we have taken 40 grams. This 8 grams which you have taken in excess will left behind unreacted. That substance will be left behind unreacted. So what leads to non-reaction of this sulfur? What is the reason? The reason is only thing, 32 grams of sulfur requires 32 grams of oxygen. So 40 grams of sulfur requires 40 grams of oxygen. Since oxygen is only 32 grams, according to that 32 grams, only 32 grams is reacted. That means in this particular reaction, 8 grams of sulfur left behind unreacted because of lack of sufficient oxygen. It means oxygen limited the reaction. Oxygen limited the reaction. This is known as limiting factor, and oxygen is said to be limiting agent. Oxygen is said to be limiting agent in this reaction. Oxygen is said to be limiting agent. That is, in any chemical reaction, if it is a stoichiometric reaction or it may be a balanced chemical equation, according to their atomic weights or molecular weights, the reactants and products will take part into the reaction. They react with each other in a specific fixed ratio. That ratio will not change. Whatever the amounts of substance that you have taken, within the available, they react with each other in a fixed ratio. So, in this particular reaction, sulfur is reacting with oxygen to give sulfur dioxide. So, you apply the atomic weights, 32 units of sulfur is reacting with 32 units of oxygen to give 64 units of sulfur dioxide. That is the fixed ratio. That ratio will not change. Suppose if you have taken one substance excess other than its ratio, then what happens? For example, here in this particular case, we have taken 40 grams of sulfur and allowed to react only in presence of 32 grams of oxygen only. Then what happens? According to this stoichiometric proportion, 32 units of oxygen reacts with 32 units of sulfur. So here, even though 40 grams of sulfur is there, the amount of oxygen present is only 32 grams. So out of 40, 32 grams of oxygen only reacts with sulfur. That means out of 40 grams, only 32 grams of sulfur can take part into the reaction to give 64 grams of sulfur dioxide. What about the rest of 8 grams? The 8 grams of sulfur left behind unreacted. So here the reaction was limited to certain extent because the lack of sufficient oxygen. In other words, oxygen which is present in a lesser proportion stops the reaction or limits the reaction to certain extent. So this factor is said to be a limiting factor. The element which limit the chemical reaction is said to be limiting agent. So in this particular reaction, oxygen will act as limiting agent. Oxygen will act as limiting agent. So this will be happen in any reaction. Now let us do some problems basing on this concept. 10 grams of sulfur was allowed to burn in presence of 8 grams of oxygen. 8 grams of oxygen. Then find the amount of SO2 formed in this reaction which element left behind unreacted and which element acts as limiting agent. So here this is the question. 10 grams of sulfur was burned in presence of 8 grams of oxygen. What is the amount of sulfur dioxide formed? Which element will act as a limiting agent? And which element left behind unreacted. So, according to the reaction of sulfur and oxygen, sulfur reacts with oxygen to give sulfur dioxide. Sulfur reacts with oxygen to give sulfur dioxide. So, if you verify whether the reaction is balanced or not, one sulfur is present in reactant side and one sulfur is in the product side. Two oxygens are there in the reactant side and two oxygens are there in the product side. Now, the atomic weight of sulfur is 32, molecular weight of oxygen is 32 and molecular weight of sulfur dioxide is 64. So, this is the proportion in which these substances will take part into the reaction. According to that ratio only, they will react with each other, not other ratios. But here what is the problem? 10 grams of sulfur was burned in 8 grams of oxygen. So, in this problem, you have 10 grams of sulfur and 8 grams of O2. 10 grams of sulfur, 8 grams of O2. According to this equation, 32 grams of oxygen will require to burn 32 grams of sulfur. That means they react with each other in equal mass ratio, that is 1:1 ratio by mass. But here 8 grams of oxygen is there, but 10 grams of sulfur is there. So, it is easy for you to identify what amount of sulfur will react here, because 8 grams of oxygen can burn only 8 grams of sulfur, because 32 grams burns 32 grams. So, 8 grams will burn 8 grams only. So, out of 10 grams, only 8 grams of sulfur will take part into the reaction and 2 grams of sulfur will left behind unreacted. So, the element which left behind unreacted is sulfur and its mass is 2 grams. So, 2 grams of sulfur will left behind unreacted in this reaction. Now, only 8 grams of sulfur was burned with presence of 8 grams of oxygen. Automatically, how many grams of sulfur dioxide will form? Just add their masses. 32 plus 32 gives 64. So, 8 plus 8 gives 16. Or in other words, 32 grams of sulfur can form 64 grams of SO2. Now, only 8 grams of sulfur was burned, though there is a 10 grams. Only 8 grams was burned. So, if 8 grams of sulfur can give how many grams? 8 by 32 into 64. 2 times, that is 16 grams of SO2 is formed. Now, note down another problem. 15 grams of Mg was allowed to burn in presence of 16 grams of O2. 16 grams of O2. Which element is left behind unreacted? Which element is left behind unreacted and what amount of MgO will be formed and which element is acted as limiting agent. So, in this single question, we have 3 questions. It is equal to 3 questions. There are 3 different questions were asked in a single question. 15 grams of magnesium was allowed to burn in presence of 16 grams of O2. Then, which element is left behind unreacted? And what amount of MgO will be formed? And which element is acted as a limiting agent? There are 3 questions in a single problem. Actually, it is equal to 3 different questions. Now, whatever the question it may be, in any this questions, particularly this type of questions, the first thing that you have to do is writing a balanced chemical equation. That was the first thing that you have to do. So, here the reaction is magnesium was burned in presence of oxygen to give magnesium oxide. Any metal when burned in presence of oxygen, it will give us the respective metal oxides, or non-metal oxides will formed. So, here Mg plus O2 gives MgO. This is the reaction. But now you have to verify whether the reaction is balanced or not. Here reactant side 1 Mg is there, product side 1 Mg, so Mg was balanced. Then oxygen, reactant side we have 2 oxygen atoms, but there is only 1 oxygen. To balance it, you have to put 2 here, 2 MgO. Again Mg was unbalanced, so keep 2 here. So 2 Mg plus O2 gives 2 MgO. Now, what is the proportions? Mg atomic weight is 24, because I already told you in your material we have already given you the atomic number, atomic weights. If you verify, you will get the atomic weight of magnesium. Now there are 2 magnesiums, so 2 into 24 units will react with 32 units to give 2 into 24 plus 16, that is 2 into 40. So, it means 48 units of magnesium is reacting with 32 units of oxygen to give 2 into 40, that is 80 units of magnesium oxide. 80 units of magnesium oxide. Now, here what are the things that we are having? 15 grams of Mg and 16 grams of O2. 15 grams of Mg, 16 grams of O2. In such cases, because in sulfur and oxygen, it is easy for us to know 32, 32. But here it is 48 and 32. So, in such cases, what you have to do? 48 is to 32. Now, you should bring any one of them to the given ratio, that is 15, 16. So, if you make it to 16, what happens? Here it 24. So, 16 grams of oxygen requires 24 grams of magnesium. But here we have only 15 grams. Here we have excess of oxygen, more than the required. So, 16 grams of oxygen can burn 24 grams of magnesium, but here only 15 grams. That means the element which is present in a lesser quantity or lesser proportion will limit the reaction. So, for 16 grams of oxygen, you require 24 grams of magnesium, but magnesium weight here in this problem, the given problem, is only 15 grams. So, magnesium is limiting the reaction. So the limiting element is magnesium. So which element is acted as a limiting agent? So here for 16 grams of oxygen you require 24 grams of Mg, but here we have only 15 grams. So the element which is present in a less proportion will act as a limiting agent. In the previous problem, oxygen is in a lesser quantity, so oxygen limit the reaction. So there oxygen is a limiting agent. Here oxygen is more than the required quantity, so magnesium is in lesser quantity. So here in this particular reaction, magnesium is acting as a limiting agent. So according to this reaction, 48 grams of Mg can form 80 grams of MgO. Then here we have only 15 grams. 15 grams of Mg can form how many grams of MgO? 15 by 48 into 80. Just 8th table. 6 8s are 48. 8. 6 8s are, that is a 10 8s are 80. So 150 by 6, and third table here we have 5. 5 3s, 2 3s, 2 here 5 times. So this is 25. So from 15 grams of sulfur magnesium we can form, it can form 80 grams of MgO. Is it correct? 6 8s are 48, 10 8s. Then third table, 5 3s are 15, 2 3s are 6, 2 here 5 times. So 5 into 5, 25. Now amount of MgO formed will be 25 grams. Then which element will left behind unreacted? Naturally here oxygen will left behind unreacted. So you have to find out what is the amount that was left behind. So 48 grams requires 32 grams. Then 15 grams requires how much? 15 by 48 into 32. 2 16s, 3 16, 3 5 times. So 10 grams. So here in this particular reaction 10 grams of oxygen was used, but we have 16 grams. So the element left behind is oxygen, and its mass is 16 minus 10, that is 6 grams. So 6 grams of oxygen is left behind unreacted. Magnesium is acts as a limiting agent. The amount of oxygen left behind is 16 minus 10, that is 6 grams. The amount of MgO formed will be 25 grams. Let us do another problem. Calculate the volume of CO2 gas liberated when 10 grams of carbon was burned in presence of 16 grams of O2. 16 grams of O2 which element is left behind unreacted, which element is left behind unreacted, and which element acts as limiting factor. So calculate the volume of CO2 gas liberated at STP, because it is important, because we can measure the volume when the temperature and pressures were given. So calculate the volume of CO2 gas liberated at STP when 10 grams of carbon was burned in presence of 16 grams of oxygen. Which element is left behind unreacted, and which element acts as a limiting factor? Which element will act as a limiting factor? So this was the question. So what you have to do now? The first thing for such type of questions is write the chemical equation that was involved in it. That is, carbon was allowed to burn in presence of oxygen. So for this reaction, the required equation is carbon, C stands for carbon, and when it burns in presence of oxygen, O2, it will gives us CO2. C plus O2 gives CO2. C plus O2 gives CO2. Here, if you observe, first you have to, what you have to do after writing the chemical equation, you have to verify whether it is balanced or not, because unbalanced equation is not suitable for stoichiometric calculations. So first thing that you have to do is you should verify whether the reaction is balanced or not. Now here one carbon atom is there, one oxygen molecule is there, and one CO2 molecule is there. Now if you observe, one carbon is in the reactant side and one carbon is in the product side. Two oxygen atoms are there, two oxygen atoms are there. So that was balanced. Carbon was balanced and oxygen was balanced. Now if you apply the atomic weights and the molecular weights whenever it was required, you will get the ratio. Here atomic weight of carbon is 12 and molecular weight of oxygen is 32 and molecular weight of carbon dioxide is 44. Now 12 units of carbon is reacting with 32 units of oxygen to give 44 units of CO2. 12 units of carbon is reacting with 32 units of oxygen to give 44 units of CO2. That means 12 grams of carbon can react with 32 grams of oxygen to give 44 grams of carbon dioxide. And this carbon dioxide will occupy 22.4 liters at STP. So the volume of this gas is 22.4 liters at STP. 22.4 liters at STP. So the reaction is always in this formula only. So 12 grams of carbon reacts with 32 grams of oxygen to give 44 grams of carbon dioxide. 12 kilograms of carbon reacts with 32 grams of oxygen, 32 kilograms of oxygen to give 44 kilograms of CO2. 12 tons of carbon reacts with 32 tons of oxygen to give 44 tons of CO2. So it is always in this proportion only. If you decrease it, that means If you take only 6 grams, the 6 grams will react with 16 grams to give 22 grams. That means if you take 6, 16, 22. If you take only 3 grams of carbon, it reacts with 8 grams of oxygen to give 11 grams of carbon dioxide. If you take 1.5 gram of carbon, it will react with 4 grams of oxygen to give this 5.5 grams of CO2. It was always in that proportion only. That proportion will not change whatever the amounts that you have taken. If one of the reactant is in less in proportion, what happens? One is according to the proportion, but other one is not according to the proportion. What happens? If you take any substance in excess, other than this proportion, that excess amount will left behind unreacted. And the substance which taken in a lesser quantity or lesser proportion will limit the chemical reaction. So that element is said to be a limiting element, and that the phenomena is said to be a limiting factor. So always they should be in this proportion only. According to the stoichiometric proportions only, they will react. The reaction will not goes on completion if any substance is present in a lesser quantity. Now, let us come to the present problem. What they have done? 10 grams of carbon was burned in presence of 16 grams of oxygen. 10 grams of carbon was burned in presence of 16 grams of oxygen. So generally they will give the proportions according to our convenience only, because this was halved, 32 was halved. Automatically the required carbon amount will be 6, you need not again calculate, or else if needed you have to calculate. But in the most of the cases when they are giving problems, in a simple manner they will give. For 32 grams it was 16, it become, so 12 should become 6, or else you have to calculate like this. 32 grams of oxygen reacts with 10 grams. Then 16 grams of oxygen reacts with how much? 16 by 32 into 10, so 2 times. So, sorry. 32 grams of oxygen is reacting with 12 grams of carbon. Here 32 grams of oxygen is reacting with 12 grams of carbon. Now we have only 16 grams. So 16 grams of oxygen will react with how many grams? So 32 grams of oxygen is reacting with 12 grams of carbon. Then 16 grams will react with how much? 16 by 32 into 12. 2 times it is 6. So 6 grams. So if it is not given, you should write like that, 6. But here how many grams of carbon was given? 10 grams. That means the whole carbon is not going to react. The whole carbon is not going to react. So out of 10 grams, only 6 grams of carbon will take part into the reaction, and the 4 grams will left behind unreacted. Now, if 6 grams of carbon combines with 16 grams of oxygen, it will give us 22 grams of CO2. Just adding 22. But here they ask us about the volume at STP. Again the same thing. 44 grams is 1 mole of CO2. 1 mole of any gas will occupy 22.4 liters. 1 mole of any gas at STP conditions, it will occupy 22.4 liters. But here we have only 22 grams. So 44 is the molecular weight of carbon dioxide. So 44 grams is its gram molecular weight. So 44 grams, if 44 grams occupy 22.4, 22 grams will occupy half of it, that is 11.2. So this is the volume of oxygen that liberated in the reaction. Now write down the steps. So in this particular reaction, what are the questions that they have asked? Which element is left behind unreacted? The element left behind unreacted is carbon. Because 10 grams of carbon was given, only 6 grams were reacted. So the element left behind unreacted is carbon. Sometimes if they ask us amount also, what is its amount? So the amount of carbon left behind unreacted is 4 grams. The element left behind unreacted is carbon. The weight of carbon that left behind unreacted is 4 grams. Next, the amount of CO2 formed is 22 grams. And its volume at STP. The amount of CO2 formed in the reaction at STP conditions is 11.2 liters. So they may have like, sometimes they may ask us number of molecules also. If they ask number of molecules, this 1 mole, 44. 44 grams of CO2 contains 6.023 into 10 to the power 23 molecules. Then 22 grams contains half of that. That means 6.023 into 10 to the power 23 by 2. That is 3.0115 into 10 to the power 23. These are very simple reactions. But students will have more confusion in this topic. The stoichiometric chemistry is most important topic in your future examinations. In intermediate in MSET examinations, nearly 25% of questions are directly or indirectly related to this stoichiometry. So whatever the problem that was given in the examination, it has certain relation with this stoichiometric calculations and mole concept. So it should be very cautious and you should take utmost care while learning this topic because it's the most important topic in chemistry.